Good morning. Welcome to Lesson 9 of Algebra 1 with Miss Barrett. Today, our objective is hopefully we'll be able to solve quadratic equations by factoring. So far we've been factoring the quadratic equations. We've been finding factors. Now we're going to discuss why we find the factors. And the factors help us to solve quadratic equations. And in a moment, you will totally understand what that means. So before we start looking at solving quadratic equations, let's talk about what x-intercepts are. The x-intercepts of a quadratic are where the graph or parabola of a quadratic equation touch the x-axis. So it's basically where the graph intersects the x-axis. And we've seen this before when we discussed the characteristics of quadratics. Okay, now x-intercepts can also be called roots. Okay, zeros are some very common terms. We also call them solutions. Okay, so if I say the words x-intercept, or if I say the words zeros or solutions, I'm talking about the same thing. Okay. So if we look here at these graphs, okay, so solving quadratic equations graphically. So this graph represents a quadratic equation. And again, we call these shapes, this U shape or this mountainous shape, a parabola. So if you look at the parabola, the x-intercepts are here and here. This is where they intersect the x-axis. Okay. They touch the x-axis. Now we would write this as the solution x equals -4, 0, or you can write it as, and which I prefer, is x equals -4, 0, and x equals 0, 0. Because these are the points where the graph touches the x-axis and y is 0. Okay. So whenever you're writing an x-intercept as a point, you always have to write whatever the number of the x is and then 0, because always in x-intercepts, the y value is 0. Okay, so this would be your answer. All right, again, let's look at this second one. We have this parabola here that represents a quadratic equation. Now, if you can look here, this is our x-axis. This is our x-axis, but as you can see, the graph does not touch the x-axis at all. Okay. So what we say here is that not that there isn't any solutions, because once you get further into algebra, like Algebra 2, you realize that there are solutions, but there are no real solutions. We say no real solutions. So if the graph is not touching the x-axis, we say there's no real solutions. Okay. And last but not least, I'm going to make this a little darker. Here we have a graph where if you see the parabola only touches the x-axis once. At this point, 0, 0. So here there's only one solution, and the solution is x equals 0, 0. Okay. So now looking at all of them, we have different situations possible. We have a situation where the parabola touches the x-axis twice, which is usual, and then you write it out as 2 points, where x is the number where the graph touches the x-axis, to 2 numbers, and then the y value is always 0. Then you have a scenario where the graph does not touch the x-axis at all, and that's when we say you have no real solutions. Lastly, okay, the scenario is where the graph only touches the x-axis once. Now, for this problem, it touched the x-axis at 0, 0. There could always be a scenario where it touches the x-axis somewhere else just once, such as this, where then the answer would be x equals the point, what is this? 1, 2, 6. So 6, 0. Okay? And that would be your answer. Okay. All right, now, when we're solving quadratics graphically, it's visually much easier to see. However, when you are given an equation like so, you have to use factoring method in order to solve these quadratics. Okay? So the steps are move everything to one side of the equation. So you're going to have an equation here, and sometimes everything won't be to one side. The goal is to make them equal to 0. Make the equation equal to 0. Okay? Then you factor. Depending on the type of quadratic, you have to decide whether to use the GCF method, the trinomial when a is equal to 1 method, or the grouping method. Okay? Set all of it equal to 0 and solve the equation separately, and you'll see what I mean. So here I have x squared plus 2x minus 24. I don't have to do step 1 because it's already equal to 0. So then I start with step 2, is to factor. So I'm going to use my trinomial with a is equal to 1 method because a is equal to 1. So I have to find the factors of c, which is negative 24, that add to make b, which is positive 2. Again, here a is equal to 1, b is equal to 2, and c is equal to negative 24. Okay, so my factors of negative 24 are negative 1 and 24, negative 2 and 12, negative 3 and 8, negative 4 and 6, and then I think it keeps going, keeps rolling. It could also be 1 and negative 24, 2 and negative 12, 3 and negative 18, negative 8, and then 4 and negative 6. Because that 24 is negative. Okay, so let's see which one adds to make positive 2. That would be negative 4 and 6. Because negative 4 plus 6 equals positive 2. So now I'm going to write out those factors as x minus 4, x plus 6 equals 0. I have to have my equals 0 because this is an equation here. I'm not just factoring a polynomial or quadratic. I'm factoring this equation of a quadratic, which is a difference. So now I have to solve. Okay, so I factored. Step 3 says solve. Okay, so I'm going to set each of these equal to 2. So x minus 4 equals 0. equal to 0. And then x plus 6 equals 0. That's step 3. I factored, I found my two factors. I'm going to set both of them equal to 0. And I'm going to solve them. So I'm going to solve for x. So this was step 1 and 2. Okay, I factored it. This is step 3. And now step 4. I'm going to solve them. X minus 4 equals 0. If I'm solving for x, I'm going to add 4 on both sides. I get x equals 4. Okay. On this side, I have x plus 6 equals 0. I'm going to solve by subtracting 6 on both sides. I get x equals negative 6. Now I'm going to write them out as points, which is the preferred way that I like for the answers to be written out. So that means the solutions are 4, 0, and negative 6, 0. Okay. If I was to sketch this answer, it would look something like this. Negative 6 and 4, and this would be my parabola. These are my solutions. Okay. So the only step we're adding really when it comes to finding solutions is that you have to now, after you factor, you have to now make your factors equal to 0 and solve for x. That's really the only thing we're adding here. So let's look at number 2. I have x squared plus 3x minus 8 equals 10. First step says to bring everything to one side. So I'm going to subtract 10 on both sides. Now when I subtract 10, I can only subtract it with a like term. And the only like term here is negative 8. These cancel on this side. I'm left with x squared plus 3x. Negative 8 minus 10 is negative 18. Equals 0. The whole goal for step 1 is to bring everything to one side, which makes the whole equation equal to 0. Okay. So now I have here a trinomial where the a terms equal to 1. So I need to find the factors of c that add to make b, and c here is negative 18. And I want them to add up, I want the factors to add up to positive 3. So that's going to be factors of negative 1 and 18, negative 2 and 9, negative 3 and 6. And I think it just keeps going on. So now it can be 1 and 18, 1 and negative 18, 2 and negative 9, or 3 and negative 6, because that 18 is negative. Well, which set add to make positive 3? That would be negative 3 plus 6 equals 3. So again, I'm going to write those factors out. X minus 3 times x plus 6 equals 0. Don't forget your equals 0. That was my step 2. I factored it. Now my step 3 says make both of your factors equal to 0. And solve for x. Add 3 on both sides. Here I have x equals 3. Subtract 6 on both sides. Here I have x equals negative 6. So my solutions are going to be the points 3, 0, and negative 6, 0. Those are solutions. I solved. I didn't just factor, I solved. Okay, next up. I have here 2x squared plus 8x minus 7 equals x squared plus 2x. First steps first. I want to make this equal to 0 by putting everything on one side. So I need to move this x squared plus 2x. Now just remember, x squared can only be combined with 2x squared because they're like terms. And 2x can only be combined with 8x. So I'm going to move them by subtracting them on both sides. Okay? So x squared was positive, I'm going to subtract it. 2x is positive, I'm going to subtract it. So it becomes 2x squared minus x squared and 8x minus 2x. These cancel out. Okay. Now I have 2x squared minus x squared, which is just x squared. And I have 8x minus 2x, which is positive 6x. And then I have my minus 7 equals 0 because I canceled out everything on this right side. If that looks a little complex, pause the video and rewind the video and rewatch what I just did. Now, if you look at this quadratic now, or this trinomial, I have a trinomial where the a term is equal to 1. Ta-da! Now I can find my factors of c that add to make b, factors of -7 that add to make 6. -7 is c, 6 is b. My factors of -7 are -1 and 7, because 7 is a prime number, or it can be 1 and -7. Which add to make 6? It's -1 plus 7. So now I'm going to write out my factor as x minus 1 and x plus 7 equals 0. Don't forget your equals 0. Now to do my step 3, I'm going to set both of those equal to 0. X minus 1 equals 0. X plus 7 equals 0. Step 4 says solve for x. Add 1 on both sides. I get x equals 1. Subtract 7 on both sides. I get x equals -7. Therefore, my answers, my solutions are the point 1, 0 and the point -7, 0. Okay. All right. Last but not least, I have here 12x squared plus 18x. This is not a trinomial at all. However, they do have a GCF. So I'm going to use the GCF method here. I'm going to use the GCF method here. And 12 has factors of 1 and 12, 2 and 6, and 3 and 2. 18 has 1 and 18, 2 and 9, we can say, actually I'm going to use 3 and 6. Okay, 3 and 6. They both have a largest factor of 6 in common in numbers, but if you look, they also have an x in common. So the greatest common factor is going to be 6x. Now what's left is going to be 12x squared divided by 6x is 2x, and then 18x divided by 6x is 3. Positive 3, and that's going to equal 0. Don't forget your equal 0. Okay. Now, I still have to separate these two factors and make them equal to 0. Okay, so even though 6x is technically not in parentheses, it is a factor. It is the greatest common factor, actually. So it's still considered a factor, okay? And I still have to solve this for 0. So 6x equals 0. I'm going to divide by 6 on both sides to solve for x, and that gives me x equals 0. On this one, I have 2x plus 3 equals 0. I'm going to solve for x by subtracting 3 first. That's going to give me 2x equals negative 3. And then I'm going to divide by 2 on both sides. Again, I'm solving for x. Okay, so when I solve for x, I get x equals negative 3 over 2. It's okay to get a fraction. Okay, it's okay to get a fraction. Do not be afraid of fractions. Just use your solving, multi-step solving skills that we learned early on in Algebra 1 to solve for x. Now I have x equals 0 and x equals negative 3 over 2. That means that the answers, the solutions is 0, 0, and negative 3 over 2, comma 0. All right. Now, I want you to make sure, I know it's a lot on the paper, but I want you to make sure that the only thing we changed here is that we took our factors, made them equal to 0, and solved for x. That's the only step we're adding here when we're solving. We've talked about factoring for about a couple weeks now. Only thing we're adding here is making the factors equal to 0 and then solving for x. Now for your practice, you're going to use your factoring skills and now your solving skills, and you're going to match the quadratics with their solutions. Okay, use your notes and each step in your notes to factor and then solve, and then match with the number here, the letter here. If you see that the letter has the solutions, so just after you factor and solve, just put the letter of the solutions here. Okay, this will be due on tomorrow, Wednesday, April 8th. And I will see you tomorrow. Bye.